Hello, in this video, we will begin to introduce linked lists, queues, and priority queues in chapter 20. In chapter 12, we introduced a generic stack class. We also introduced the vector class, which is defined in the C++ library. In this chapter, we will introduce a new data structure called linked list. A linked list is efficient for storing and managing a very number of elements. It is especially efficient for inserting and deleting elements at the beginning of a list. A linked list consists of the elements. The elements are put into nodes. Each element is contained in a node. The nodes are linked together. From this diagram, you can see that this is the linked list. This is the head of the list, and this is the tail of the list. So the node 1 links to node 2. Node 2 links to node 3. So this is all the way to the end. Nodes are objects. Objects are defined using classes. So look, this is the template for defining the node class. It has the element, and next is the pointer to the next node. There's two constructors, node constructor, and this is the constructor constructing the node with the specified element. And the next pointer is always no pointer when the node is created. Now let's look at a couple of examples for using the nodes. Let's have an empty linked list. So the linked list has this head and tail. Initially, there are no pointer. So this is an empty list now. And let's add some elements to the linked list. So let's look at this. I'm going to add Chicago. So this is the string element, Chicago, creating a node. This is the node pointer now. It's the head point to this node, and tail also points to this node. There's only one node. And let's add another one. This is Danforth now. So we're going to have this tail going to move to the Danforth. So first we link this, the first one, to this new one, and then finally tail points to Danforth. So now we add another one, it's Dallas. Dallas is going to be linked with the previous one. So the Danforth, from Danforth, you have a link next to Dallas, and Dallas now becoming the tail. We can write this loop to traverse all the elements in a linked list. So this begin with this current pointer is the head. If the current pointer is not no pointer, so please note that in this linked list, only the last one is the no pointer. When the last one here is a no pointer, means you have traversed all the elements in the linked list. So now this is the pointer, points to the node. So the current element, this is displayed. Now move the current to the next. So here is the animation to show the linked list. I'm going to enter 34. So now look, this 34, and this is 21. So this is 21. This is 26. This is 26. 26 is here. And this is 12. 12 is right here. So the last one is this next point is null. You can do a search to find is 21 in the list. So here is the search. 21 is at index 1 in the list. And let's search for 34. 34 is at the index 0 in the list. Let's search for 25. 25 is not in the list. You can also delete one. That is all for the beginning of this chapter. We will look at more detailed information about the linked list in the next video. See you on the next video.